All right, today's lesson is on probability. So before we get started with probability calculations, we need to understand some terms that are related to probability and important for probability. So the first one that we have here is experiment. An experiment is a random trial, and it's any happening whose result is uncertain. And you can fill in your notes, fill in the blank notes along with this lesson. The next term that we have is an outcome. An outcome is the possible results of an experiment. And the next term that we have is a sample space. And the sample space is a set of all possible outcomes that are in an experiment. So like if you're flipping a coin, an outcome could be heads, another outcome could be tails. So those are independent outcomes. And then the sample space would be heads, and it would also be tails, okay? And then the last one that we have for this slide is an event. An event is a subset, which is just a collection of a specific sample space, okay? So it's what you're trying to get for whatever probability you're trying to calculate. All right, the probability of an event. If an event E has, this is N of E, equally likely outcomes, and its sample space S has N of S, equally likely outcomes, the probability of event E can be then given by this formula. So the probability of E, this means the probability of event E is the N of E. So N of E is the equally likely outcomes and divided by its total values that are in the sample space. So if you write that out in words, the probability of the event is the number of desirable outcomes divided by the number of all possible outcomes. So the desirable ones are what you want to happen. And so if you're saying I'm flipping a coin and you want to figure out how many times you're going to flip a coin and you're going to get heads, then heads would be your desirable outcomes. More probability of an event. Probability is always going to be a fraction or a proportion. And whenever we're writing it as a fraction, make sure that they are reduced fractions. Or you can give decimals if you want to give decimals, especially if the information is given in as decimals, or you can also give probability as a percent. Probability is always a value that's greater than or equal to 0, less than or equal to 1. If you have a 0 probability, that means the probability will never happen. That event will never happen. And if you have a probability that's equal to 1, that event will always happen. Okay, so there's a 2, P of E is 0, and P of E is equal to 1. So then we have what's called a complement of an event, and the complement of an event is the collection of all outcomes that are in the sample space that are not in A, okay? And A, let's define it, what does that mean? Let A be an event, and then A prime, this is the notation for the complement of A. Okay, so it's just that prime complement. And if A is the event and A prime is the complement, then the sum of those two probabilities is always equal to 1. Okay, so this is the probability of A happening. This is A's complement, so that means that A does not happen. Okay, so if you would add the probability of it happening, the event happening, plus the probability that the event doesn't happen, that's going to have to equal 100% essentially, or equal to 1. All right, then we have the odds of an event. So the odds are if the probability of an event is P of E, then the odds for the event are defined by this ratio. So P of E is the probability of the event, and then P of E complement is the probability of the complement. Whoops, I should have said P of E prime. So of the complements of the event. And we know that we can also write the complement. If P of E is the numerator, the complement would be 1 minus P of E, since the sum of those two equals 1. We usually write this as a ratio of whole numbers, and either we write it as a fraction or we write it with the word 2 in between. Next, we have the probability of the union of two events. So if you have two separate events, so we have event A and we have event B, and these are events that are in the sample space, the probability of A or, notice this word or, not and, but the word or occurring is going to be given by this. So this term right here, remember, is union. So the probability of A union B is going to be the sum of the independent probabilities of A and B, and then you are going to subtract the probability of A, remembering this notation is an intersection, right? So A intersecting with B, okay? And we know that that union means or in mathematics, and then A intersection of B, that is going to mean that we're going to subtract the overlap. So it's when A and B are both happening. So we've counted those already in the probability of A right here. We've counted them in B. So we want to subtract that overlap so that it's not double counted. Okay. Then we have the term mutually exclusive events. Mutually exclusive events are just events that have no outcome in common, which means there's no overlap. So if there's no overlap, then that means that this part would be 0. And so it's just going to be the probability of A plus the probability of B. All right, moving on to independent events. So independent events are two events that are independent if the occurrence of one has no effect on the occurrence of the other. Okay, so if A and B are independent events in a sample space, then the probability that both A and B will occur, again, this is our intersection notation, is going to be the product of the probability of A and the probability of B. Now the intersection means and so because it means and, we know that we're going to multiply, versus the last slide was or, so we were adding. So these are independent events. We can just multiply them together. All right, next we have common probability sample spaces. So when we're working with probability in this class, we're going to work a lot with decks of cards and rolling dice. And so common probability sample space for cards, some things to know, is that there are a total of 52 cards in a deck. So there's 52 cards in a deck. There are 2 colors, black or red. There are 4 suits, right? So 4 suits: hearts, diamonds, spades, and clubs. Hearts and diamonds are red, and spades and clubs are going to be black, okay? So let me just write. So hearts and diamonds, these are red, and then spades and clubs are both black, okay? And there are 13 cards then of each suit, because we 52 divided by 4 suits equals 13 per suit. And then we have 13 values. So the values are the numbers 2 through 10. And then this A is an ace. And then the K is a king. And then queen. And then jack. For those of you guys that play cards, you obviously know these, but some people don't play cards, so they don't know all these things. And then we have what we call face cards. And so face cards there's 3 cards per suit. And so a king, a queen, and a jack are all face cards. So essentially they have a face on the card. So they have like a king's face, a queen's face, or a jack's face. Okay, so that's cards. So good things to know about for cards. And if you don't play cards, I would recommend, making sure that you have this close by when you're figuring out probability. Next, we have the common probability sample space for rolling 2 6-sided dice. Okay, so here it says rolling or tossing 2 6-sided dice, or this also is the same chart we're going to use for rolling or tossing 1 6-sided dice 2 times. Okay, so we have the first die is the first number, and then the second die is the second number. So you could roll a 1 and then another 1. You could roll a 2 on the first dice, a 1 on the second dice, a 3 on the first dice, a 1 on the second dice, and so on. So we can see in here that we have a total of 36 possible outcomes, right? So we have 6 in each column. So there's 6 here, 6, 6, 6, 6, and 6. And so there are 36 possible outcomes. All right. So there's a sample space for you. Okay. So I'm going to stop this video here, and then I'm going to start a second video that has the examples on it.